Hello, today is Friday, April 12th, 2019. This is the first ever sig-cluster-lifecycle new contributor meeting. So the agenda today is to basically give folks an overview of what sig-cluster-lifecycle is, what we do, give you an idea of some of the projects that we work on, and also get an idea of where you can contribute and how you can contribute. Um, so I'm going to first start by sharing my screen and give a little bit of history here. If folks want to add details to the meeting notes, they are pasted in Zoom as well as in Slack. Feel free to add your details there. So what is SIG cluster lifecycle's purpose? Like, how did we even get started? So back in 2016, to give a brief overview, back in 2016, there were only there were a lot of tools that existed out in the ecosystem around provisioning clusters. Right? And there were vendors that actually even no longer exist today too that were in this space as well. And there was this common theme that was happening in the ecosystem that was Kubernetes was hard to deploy and manage. And even with the tooling we have today, it still kind of can be a little bit difficult to do. And we keep on, with every iteration and cycle uh, inside of the sig cluster lifecycle, we try to refine it and make it a little bit easier. But what we were seeing in the ecosystem is that there were all these different tools that are essentially doing the same thing over and over again. And so we started sig cluster lifecycle with the initial scope of creating a bootstrapping tool, which in this case started out as kubeadm. So that way, instead of all of these other tools having to do the same thing over and over and over again, we had one tool that everyone could leverage and rely upon. But as we started to expand in scope over time, is we found that there are sets of things that people keep on doing. So what I'll do here real quick is I will stop sharing my screen and I will go to settings, video. Hopefully folks can see this. I'll try and zoom in a little bit. So what we kept on seeing over time was that there are sets of tools, and we wanted to be able to separate the responsibilities of those individual tools to allow folks to be able to opt into using pieces of the puzzle. So we started out with kubeadm, but then there was a need and a desire to basically split out the functionality for doing etcd management. So there's a separate tool called etcd-adm. It's still very nascent, and we haven't switched a lot of the code from kubeadm that does etcd management to be using etcd-adm. But in the fullness of time, we'd ideally like to do that. Hopefully folks can see this. If you can't, feel free to speak up and I'll try and zoom in even more. And then what happened recently is there's a desire for doing add-on management sort of outside of the core of Kubernetes. We've always done it this way. kubeadm has some inner portions of add-on management, but we want to be able to manage the life cycle of those add-ons independently. Right? So these are things like kubeproxy, core DNS, and there's a finite scope of add-ons that exists there. But basically, core cluster functionality is where add-ons live. Application space is kind of higher up the stack, and we sort of defer to things like Helm to do management of those items. The purpose of add-on management is basically have a unified way of deploying and managing the core pieces that everyone would need for standing up a cluster. And then on top of that, we have another tool that we've been working on, which is called Cluster API. And Cluster API provides sort of declarative management of deploying one-to-many clusters. Right? So as you can see, like there are several different tools, and they're meant to be composable. Right? A person could choose to use any one of these tools inside of their installment tooling that they're developing, but it's not a forced requirement. So a lot of the things we do inside of SIG cluster lifecycle is we follow the batteries included but swappable option. So that way we have a default configuration that we use, but we always want to be able to have knobs or parameters or options for folks to be able to change what they need. A great example of this is some of the things and design principles that we bake into the tools. Like one of the key things that we added in kubeadm is that even for bootstrapping, there's very opinionated ways of doing it. So we have separate phases for the bootstrap cycle, and it's basically like it's a linear DAG of a series of execution steps that go in order. And a person, if they want to, can choose to use kubeadm in the phases model. This way, they could choose to use some of the phases, but not all of them, and that allows them to be opinionated if they have a separate installer. Uh, and I'm sure we will do a very similar approach with add-ons. We've actually already started to do this with tools that are leveraging kubeadm. So Kind is starting to develop phases too as well. So it's an interesting way to approach the problem that allows folks to use it in a piecemeal fashion without having to like consume it all. What also kind of happens too is there's these weird questions that kind of exist of how you deploy or how you consume the artifacts for sig-cluster lifecycle. There are things that are core artifacts, and there are things that kind of exist outside the core. And I think add-ons are in this weird space. They're kind of like right at the surface layer, right? So currently, kubeadm is in core. I think in the fullness of time, we want to move kubeadm outside of the core. In order for us to do things like that, we want to promote other projects, such as sort of having what we call a unified component config, a way for us to be able to configure components using API types and a standard model inside of Kubernetes. So we get well-defined versioning semantics, and it allows us to basically use the Kubernetes style API for controlling components of Kubernetes. Once we have that capability, we'll probably move kubeadm outside of the core. So I'll pause here for a second because I want folks to ask questions. This is not just me doing a monologue. It's for folks to see, like, does this model make sense? Are there questions about the pieces of the puzzle that exist inside of sig-cluster lifecycle or the main projects that are there?
I'm curious why the component config is a requirement for kubeadm to move out of tree.
So the key reason why we want that as a hard requirement is because if people change the way components work and operate, and it's not a standard API, which it has happened several times over the course of Kubernetes, we end up having a broken installation mechanism for that for a given release. So we didn't used to always have policy or strict policies around command line flags. We have better policies in place now, but we have even tighter policies on API. So once an API has gone to V1, we have some level of guarantee that a change in the core should not break the installation utility. But there's other logistical reasons why we want to wait to move it out. The federation of repositories inside of the main of Kubernetes system is not, it's like a half start that is like stuck in this limbo state that has existed for a long period of time. Because how we do sort of release versioning across a federated set of repositories has never actually been fully flushed out. So if a person wants to get a Kubernetes for even the core set of things, we don't actually have a release bundle that exists today that isn't straight out of KK. So like they'd have to go to all these separate repositories to get a Kubernetes. And the promise, at least the original stated promise, is that if we had all these repos, we would have a way of basically combining the bundle together to get a core release for a given release cycle. So there's a bunch of constraints there.
So a question here, this is Michael, sorry. So basically the model, I'm sure I'm not fully understanding it yet. But the idea is to basically the hook merge connect all this separate pieces by well-defined and well-maintained set of APIs, so that replacing one portion will guarantee that the rest don't break. Is that the idea? Do I understand it correctly?
Yeah, if you're moving kubeadm out of core, then yeah, that's one of the requirements. There's a couple of other constraints that I was mentioning that currently exist as well.
Thank you.
Yeah.
Wondering if you could expand a little on the scope of add-ons. Is that just core Kubernetes components like the DNS, or would that include like third-party CNIs, or sort of where does that stop in your mind?
I think that's to be determined. So in my mind, CNI is outside the scope of probably a bunch of the add-ons, but I don't think I think it could be included. I think right now add-ons is very alpha. It's pre-alpha, right? So at this stage, it's to be determined. Ideally, the promise of add-ons, or the idea of add-ons, is instead of folks having to grab YAML manifests and bundle them into these other tools, is we basically have a tool with a single manifest that manages them all for all deployments and manages the life cycle of all these different things. So if you go to different tools today, such as like kubespray or kops, right, for a given version of Kubernetes, it's possible today to have different versions of add-ons, right? And it depends upon where you are in the stack. And ideally, we don't want to have that fragmentation in the fullness of time. We would rather just rely on a single canonical source of truth. And that way, GKE, kops, kubespray, et cetera, just all reference the same version and do lifecycle management through the add-ons, add-on manager.
That makes a lot of sense. I'm mostly observing that I have the same problem with like that's the core bundle, and I have a bundle of components that basically is shaped the same way, but it's something I put together, right?
Yeah, and that's pretty common, right? So I mean, like that's what higher level installers kind of do, is they basically bundle all the other pieces, right, that they need for a Kubernetes cluster. And some of those things include core add-ons, and that set of add-ons could be fundamental, or it could be a larger set. Like some people want the metric server and all this other stuff that comes along with your core deployment, and that we're trying to bundle those things and have a way of unifying a configuration for installing those within the add-on subproject.
Will that apply to all add-ons? Basically, it's a uniform data model for any and all add-ons that anyone would want to add to their deployments, however big or small.
That's the premise. We'll see how it rolls, right? Like usually what happens with inside of projects and sig-cluster-lifecycle is that like out of all these projects, only this one is GA, right? We go slow, and we go slow on purpose. And we're try to be pretty methodical with our releases and try to have backwards compatibility support even for alpha things. That way we get feedback from the wild at regular intervals for us to be able to know if we're going in the right, if we're trending in the right direction, and if it's generally useful. So I expect, we'll probably have an alpha release this year for add-ons, and we'll try to get more feedback. And ideally, we try to incorporate that into the other projects as well to get broader feedback.
Understood. Thank you so much.
Mm-hmm.
I have an anecdote kind of related to the current situation with kubeadm in particular. So I was building an implementation of Cluster API, and this turned out to be just kind of like an implementation detail with kubeadm, but some of the functionality was only exposed in flags, and if you used those flags, then you couldn't use the API. And there's like a whitelist mechanism now in kubeadm of flags that are allowed when you're also using the API. So I think we want to keep in mind that we have a core API, but also all of the functionality can be overridden when that API is invoked.
Mm-hmm. Yeah, so
yeah.
that, like I mentioned before, like the machination to get to a place where you had enough base capability for 80% use case, along with the capability of satisfying the assorted 20%, that last 20% is actually super duper hard to satisfy. Like what we found is that, you can make the base case really simple and turnkey, but then if you actually look at the sheer number of phases and knobs that actually exist inside Kubernetes, it's a lot. Like it's a lot. And that took a long time to get to even where it is today.
Yeah.
And it's still missing features, in my opinion, for where we ideally want to get it to.
Yeah, and I'm saying the API is great, and I love how quickly it's advanced. But if there are flags that we just, I think it's kind of strange that there's a white list of flags that are allowed when you use the API. Like, why not allow all flags when the API is used? That's what I mean. Yeah.
It had mostly it's due to feedback, and we didn't want combinatoric explosion, right? So like what we had originally is we pruned a bunch of the flags out before we actually even went to beta. So we had a combinatoric explosion of options that existed through, I would call it API, I call it configuration file, because it's not really an API. So the configuration file for Kubernetes got massively pruned before it went to beta because we didn't want to expose or manage all of these things. And we also envisioned that the component configuration for some of these things should be its own API. And what was kind of happening is Kubernetes was kind of subsuming a bunch of the component configuration for these other things. So instead, we kind of made it explicitly dumb on purpose. We have a general catch-all option to specify command line flags down to the individual components, but we didn't want to sort of conflate the configuration for Kubernetes with all the different sub accoutrements that can exist, right?
Sure. Yeah, that makes sense.
Yeah. So I think in the fullness of time, I keep on saying that phrase over and over again, that component config will be the way to configure most of your components for most of the core Kubernetes components. There will also be some version of that configuration for the add-ons, likely too.
I have a question, Jim, about component config. Do you see that as something that operators would use to kind of deploy and manage the lifecycle of their own components as well, or is that kind of specifically focused on components that are owned and built within the community?
It's meant to be a reusable library. So Mike Toffin and Lucas and Stefan have been working on this as a general purpose library, as well as a set of APIs to be used by the components, right? So it's meant to be composable, in part because other people want to use that same style of generating component configs for their own components, whether they be custom controllers that they write or operators that they write. They want to have a unified way of configuring and managing them.
Cool. Yeah, that makes sense, I think.
Mm-hmm. Other questions? I can keep on monologuing and then just see what other questions folks have. So currently, where are we kind of at today? So like I mentioned before, Kubernetes is the only piece of the puzzle that's GA. Cluster API recently released a V1 Alpha 1. But again, much like Kubernetes, we released something to get it out there. And it's going to evolve over time. So the model we have today will likely take a while for us to settle to be able to understand where the boundary lines of cluster API are and where we want to stop things. Because there's two separate pieces inside of cluster API. There's the machines and the cluster API. And clearly defining the boundary lines of where one begins and what responsibilities exist there and where the other one ends is going to take a while.
So I'm very new to Cluster API. I've kind of tinkered with it and just got as far as the end of the book, which is pretty useful. Thank you. Do you see cluster? So one thing I noticed in the versions API part of it, I think it's pretty specific around there. I think there's a version of the control plane, there's a version of kubelet. Do you think that versions will kind of grow to be able to manage the sorts of components that component config deals with, or will those concerns likely to remain separate?
That sounds like a separate concern for the version of the individual components, but the supported deployment versions, hopefully in the fullness of time, again, I'm using that phrase again. Currently, this is going to be V1 Beta 2 for its config. And then as we push that over time to get that to actual V1, once you're in a V1 state for all of these things, I think it won't matter. And the cluster API should be able to deploy this suite of supported versions for when it releases. But that's highly dependent upon us getting to V1 APIs, which takes time. Those are not easy to do. And history has taught us that it takes on the order of a year plus to get to a V1 API.
Mm-hmm. Thanks.
Yeah. So what was happening, or what we were seeing, and I'll monologue a little bit about this, is that it was kind of commonplace for folks to have one cluster, right? They were using several different tools. They were using maybe KubeSpray or Kops, or some other custom installer that used pieces of these puzzle, or they did it on their own, right? And that was great for installing and managing one cluster. But then it became more difficult as they were trying to install and manage N clusters, right? And the pattern we were seeing in the community is, and we have like stats on this from feedback from the wild, from surveys that we've done, is that the average people who are managing clusters have around about between 5 and 10 different clusters inside of their IT organization. Some people have very interesting environments. The more automated you get, the more clusters you have a tendency to see. So this is the average, but people who are highly automated, they have on the order of like 10, hundreds to thousands of clusters. And once you start getting into that space, your standard tools start to break down a little bit, because you need constructs that allow you to manage higher up the stack and do it in a more abstract way, right? So that's exactly where Cluster API aims to solve that problem. You can use it for managing. I personally think, this is my personal opinion, if you're trying to manage one cluster using Cluster API, it's kind of overkill. Once you start getting between 2 and 3 and higher, then it starts to make a lot of sense, because you want to have a unified way of managing your clusters over time and being able to upgrade them. What do folks think about that?
I think it makes total sense. It's just manual approach only works so far. I mean, we're seeing it. So it's the more distributed you go, the more automation you get, the more stuff you put out there in the containers, deploy it in the clusters. It's just basically, you can't. I mean, how many people are you willing to hire?
Exactly.
Yeah, I would echo that. Like, I think Kops did build part of this, but I think, so in other words, you can like list multiple clusters and manage multiple clusters individually through like one pane of glass. But I think the real power of the Cluster API is that you get a real Kubernetes API, and you can use the tooling like Customize or Helm or whatever tooling you're using to actually manage multiple clusters sort of homogeneously, or like in bulk, rather than treating them as onesies and twosies.
Yeah. In the future, you could kind of even envision like a GitOps type scenario where like you do a push to a repo, and that push to the repo automatically provisions you a templated style cluster for your environment. And that gets you out of the state space of having this sort of ticket driven system where the ticket could actually be a PR, right? Because if you actually look at a lot of IT shops, it's like, you know, my new acquired employer still has like, you know, a lot of manual ticket driven processes, and you go to any large organization IT shop and it has that too. But if you can get to the point where you have a GitOps style environment, you could auto provision these things in a much more systematic, clean, automated fashion.
Like Terraform?
Well, it's declarative like Terraform.
Yeah, right. Mm-hmm.
Yeah. Not Terraform itself, but the backend.
Yeah, of course. Mm-hmm.
If we consider what might be the next line under there, which would be the next order of magnitude or even beyond that, then Cluster API makes a lot of sense. And some of these issues that we encountered with kubeadm was kind of related to those limitations that you mentioned of you know, using kubeadm for 5 to 10 clusters. So there's always the feature creep of considering extreme use cases, but I think we really should keep the extreme use cases in mind.
Yeah, well, I think that what we were trying to do is solve problems for each layer of the stack. And that's kind of why I drew it this way, is that there's a domain of problems that it's addressing, and each one is unique. And they're trying to not, even though they currently do kind of bleed over into each other, which right now, but in the fullness of time, as I mentioned, we want to make these clear boundary lines, good Lego blocks that you can build with. And a person that wants to build with them can use these Lego blocks, or they can swap out this piece and put in another one. Right? That's the basic premise. But doing this is actually really hard. It's a lot harder than just making a monolith, because with a monolith, you can just assume all the responsibilities and then try to give you one layer atop. But making it in this fashion is proven fruitful as far as engineering, and it's also very interesting, but it takes a long time.
I think the other risk of that approach is that it's pretty confusing for newcomers, which is why I think this talk has been pretty valuable for me. Because so maybe, I don't know, if we can collaborate on some kind of just simple roadmap or simple map of the landscape page, because when you have these little components, that this is a component-oriented approach, when you need to have kind of help a little bit of hand-holding to get a mental model of you know, those relationships.
That is true. And this is kind of why I wanted to have this, because I do realize from the external observer, there's a ton of implied context, right? A lot of the people who are working in this core SIG, like Justin, myself, Jason, we've been doing this for years. So we have this model baked into our brains, and we know how the whole system functions, and we know how to stripe across horizontally into these different projects. But to the external observer, it's opaque. That's part of the reason why we want to have this talk. But having a unified roadmap is kind of hard, because they release at different cadences. Perhaps making like this model more explicit in documentation form, and pointers to where people are at with their own roadmaps, that would probably be a potential approach.
Yeah, having like an overall architecture with some sufficient level of details so people know where to go for, you know, if they want to dig deeper.
Yeah.
Would that work?
Yeah, that seems reasonable. I would probably put that in the main community repo alongside of the main documentation that exists currently today.
Yeah, I think this diagram is a pretty good starting point.
Mm-hmm. One thing you always find is that every time you start a diagram, you'll find it's deficient in some way, shape, or form. So like we had a legacy diagram, which is actually in the doc, and that's we found it to be lacking in many ways over time. But I think this gives folks at least enough context to have a conversation to understand where one tool begins and the other tool ends. We're currently having this debate right now inside of the Cluster API. I don't know if the cluster API folks want to speak to it a little bit about where one tool ends and the other, or where one idea ends and the other idea begins. I think that's a good conversation to sort of give folks an idea of the debates that we kind of have. Andy, Vince.
Yeah, I can talk a little bit. So we are trying to take Cluster API and just refine the project mission and scope and requirements. And we're thinking long and hard about a better separation of concerns than we currently have right now. So nothing is set in stone, but like potential items include taking what is currently a machine resource that cobbles together the underlying infrastructure and what's installed on it and configured, and potentially trying to find a better set of abstractions that break things apart. So it's not one machine equals infrastructure and configuration, but at the same time, we want to make sure that we stay true to the project's underlying mission, which is managing the lifecycle of Kubernetes clusters. So we don't want to have these discussions about changes to, or possible changes to APIs without keeping that broader context in mind. But we are definitely appreciative that like in pretty much every software engineering effort, you do want to have separation of concerns. So that's what we're looking at doing.
One example of this too is that the cluster API for most of the providers, they have this idea of using images, and it's kind of out of scope for cluster API to do image management. So one of the things we're kind of talking about is the potential for another sub project that which would be down here, which would be like the stamper, right? Where and we've talked about this many times in sig-cluster-lifecycle, is just being able to create immutable images with the core pieces that you would need, as well as any user-specified options, and be able to produce immutable images for your infrastructure for all the different major providers, and including, you know, on-prem styles providers. So you'd have OVAs, AMIs, whatever Azure things are, and other images of other kinds. But this way, in doing this model, is that this thing would be a totally separable piece where Cluster API just uses images that could be stamped or minted via the stamping utility. So that sort of, you know, create something new, then find out where the boundary lines are, then iterate, and trying to tear apart the model is kind of how we've done things over time. Like etcd ADM never really existed in the beginning, but it makes a ton of sense to tear those pieces apart. And the add-on management didn't really exist, even though we talked about it since like the beginning of the projects. I see Justin smiling. I mean, we've been talking about it for years, but it's actually coming to fruition. You know, people are actually working on it. Fingers crossed.
Could you please elaborate a bit more about the stamper story, if that's within the scope of this conversation?
Sure. Like, so image stamping, like one of the things that we've seen over installation across any one of these utilities is that mutability it becomes very difficult to manage if you have a cluster that mutates consistently over a long period of time. So imagine you had a V114, and this goes to some of the basic concepts that are inside of, that we baked into some cluster API. If you have 1.14, and then you go to 1.15, and then you go to 1.16. And if you keep on mutating that cluster over time, you find that the combinatoric explosion of installation of software packages and everything else, and the accoutrements and the security concerns just explodes, right? So what we want to do is mint a new image, or have a utility that folks can mint their own image that allows them to basically roll in brand new machines with the golden minted images. This gets us out of the place of in-place upgrades and has more of a rolling mentality, very analogous to how Kubernetes does it, manages its own applications like deployments, right? The idea is to use the same model that Kubernetes uses for managing applications for managing clusters.
Thank you. Thank you. It makes total sense.
Yeah. So like you shouldn't be mutating an upgrade for, if you are, you're kind of using Kubernetes in the wrong way of mutating the images. You have a new version of your application. The one thing we don't really support in cluster API is canaries, and I don't think we should, although we might want to have the idea of that, right? I do think that we should, over in the fullness of time, have some forms of strategies that are more sophisticated than just kind of rolling it out there.
One thing I want to add to Cluster API is something that helped along the way, like separate the concern, is something that it's an actual work stream right now that we're working on, is to define an extension mechanism. We're talking about separating concerns, and one thing is like we have these gaps, right, between what we want to achieve and how we want to achieve it. So it helped like define this generic like extension mechanism that we see as a black box. It pretty much says we have some actions that we want to define. For example, like a bootstrap a node or join a node to a cluster. And we define this as an action, and then we fill in the gap, for example, as with the default implementation of kubeadm. So kubeadm will fulfill their purpose for now. And if like in the future, there's going to be, I don't know, kubeadm version 3 or something, we'll be able to like have another box on the side like that can grow on its own, and then like put it in and use it. That's all I wanted to add.
I think the one pattern that we kind of see that we do inside of sig-cluster-lifecycle is, old school is like a scatter gather, right? So we basically see this inside of providers today. So like you have P1, you have P2, you have P3, you have P4, right? And the original implementation of cluster APIs, and this also happened with a lot of the other tooling as well. Even the very basic installation is there were dozens of installers. Then we distilled it down into like a central atom, right? It's okay for fragmentation at the start. Don't try to create abstractions that inherently become leaky. Like allow the ecosystem to sort of evolve, and then over time distill the patterns down into a common set that is usable by the broader ecosystem. If we tried to create the abstraction first, you inherently create these weird leaky abstractions that kind of happen. And you see this in all the other tools. Like you see this in every configuration management tool that has ever been created. So the goal of this is to learn from the lessons over time and only create the abstractions once we are concrete that this is what we want to do. But another thing that's a central premise to all of these tools is that we are not creating abstraction layers for clouds. That is not what we are doing. Everything is related to Kubernetes management. And the abstractions are around, the basic premises of the abstractions are around clusters and clustering and cluster utilities. So in this case, the basic premise is around SCD management. This is around the basic premise of an individual cluster. This is the basic premise of multiple clusters, right? So this scatter gather mechanism takes time, right? So,
hey, Tim, so that makes perfect sense. You don't want to try to model clouds or build those tools. But what is the cluster API in order to implement a cluster needs some underlying API, some underlying layer to provision those things. And right now that's done in the provider. And I guess the question is whether there's more abstraction that can be made over there. And how do we address how do we make sure that the machine controller is completely separable from the provider can be split into multiple parts that are that can be adopted independently as opposed to having to take the whole thing at once?
I know, is Jason on? I know he's thought a lot about this, and so is Vince.
Yeah, so it's it's difficult to say right now because anything I'd say would be really hand wavy because we're getting ready to break into the different work streams and actually define what all of this looks like. Um, but the goal essentially is to really define more tightly scoped interfaces around the different extension points more so than we have today. Today we have this kind of concept of just like one monolithic provider, but we want to kind of break that up a little bit more so that it's a little more granular um, for a few different reasons. One, we want to be able to have things like common config, regardless of what cloud or hardware you're running on. So we want to be able to break that out separately from kind of the infrastructure kind of providers. The other aspect is if we start talking about being able to handle like bare metal environments, we need to be able to have kind of more granularity around which providers provide what components, because right with the state of the world today, you would basically have to build a custom monolithic provider for just about every bare metal environment because of the different combinations of infrastructure providers that
Right.
are required to provision all the hardware. That said, we also realize like cluster API is a big thunk to kind of consume all at once. So if we want to let other kind of infrastructure tools have a method of adopting cluster API, we need to have a more formally staged kind of on-ramping process to enable that instead of, okay, here's this cluster API thing, just, rebase all of your stuff to just work with this is not overly going to be feasible. So, we want to make kind of like a staged adoption path so that, obviously you can start with machines and then you can bring in some of the additional management pieces and what exactly that looks like. Don't know yet, but it is something that we identify the need to kind of have.
And I guess or is it in the scope of cluster API? So when you provision any cluster, there's different pieces that need to go in. Like for example, if you're doing I think this is what you're talking about, right? You do a bare metal environment and you want load balancer services to work, and they have F5s or they have, I don't know, something else. Then you're going to deploy different controllers. And so, do we have or is there an idea of what are the abstractions required to create a cluster? Like the cluster consists of, I know we talked about a little bit, like there's a control plane, maybe abstraction we're working on. And so there's the nodes and there's the control plane piece. Like what are the granular abstractions, or are they impossible because it's an opinionated, it depends on your opinionated deploy, what those abstractions even are. So I guess that's what's not, I'm trying to understand what we think is achievable and where we draw the line of what we try to do and not do.
So this trends a little bit into speculation here, obviously, because I don't want to step on the work stream that's going to have to define this out. I don't want to necessarily, try to influence that in any way, but I do think we can get more granular than just what we have today, which is like cluster for kind of the infrastructure components.
Right.
In my mind, I see you would have kind of like a load balancer would be kind of a common kind of granular piece of abstraction. Maybe like network so that you could interact with potentially networking equipment. If you're provisioning bare metal and you have to wire it up into, a proper VLAN or whatever, something to enable that type of wiring. And then firewall is another one that I see. Mm-hmm. Because I've seen plenty of kind of bare metal environments where those are like 3 different distinct providers. So I think if we provide that level of granularity, it doesn't, it might create a little bit of an odd workflow for a cloud provider where all of those are kind of the same interface. But I think that would potentially provide enough flexibility for the on-premise environments. That said, the work stream is still
Okay.
Yet to go. So let's. I think we can achieve something. What that ends up being, we'll have to wait and see.
Right. Thank you.
I want to give one last chance for questions on this basic model before I started talking about how folks can engage and how we kind of break down work items and how we operate. Are there any last questions about sort of the model and sort of the pieces of the puzzle and kind of how they fit together, other than we definitely hear that we should do a better architectural documentation and try to get links out to other folks?
I have a specific question about machine version info struct.
Okay, that's
yes. So the kubelet, in there you have kubelet, a string for kubelet as a semantic version of the kubelet. Is that intended to be kind of a logical version for a kubelet and all the other packages which it interacts with, like CNI or the containerizer or whatever? Or is that supposed to be specifically for the kubelet binary as released by the main Kubernetes project?
So as of today, it really isn't defined how that behavior is supposed to be. I do think that is something that we potentially want to define better going into the future. I can say what we do with the AWS provider for Cluster API right now is we basically just kind of, we stick with just a single CRI implementation, which is containerd, and we basically just kind of like rev the dependencies when we'll rev the Kubernetes version. But the selection that we do is basically to filter pre-existing AMIs with the AWS provider as well. So we could easily still keep that same model and extend, those other components and versions, and just kind of like do more granular filtering on the images that are there. Some of the other providers don't use pre-baked images today, and they'll basically just install the latest version of whatever their kind of predefined opinionation is around those things at the time of bootstrapping. But this is something that I think we want to have more control over in the future, but is kind of yet to be defined with the work streams.
Cool, thanks.
Tim, you're muted if you're talking.
I was talking. I said the question is interesting because it conflates two ideas. One is a single field, but there are multiple components. And ideally, I would like to see some level of providence built into things like add-on management that says this is the 114 stream of vetted add-ons for a given release. It's been branched, it's been versioned. And that way folks can rely on that for a given release series. Because that's the way qualification currently happens in upstream. The difference is that it's monolithically baked into things like Kubernetes, as well as the /cluster directory today. All right, so engagement, we got 10 minutes. So I will switch back and I will start to share my screen here instead. All right. So first things first is like, how do we work? We work in a very similar model that we've kind of developed across. It's not the same for every single sub-project, but most sub-projects kind of adhere to this, is that we try to just basically create a milestone. And for things like Kubernetes or things that are core, we have the release milestone that we have to adhere to, whether by hook or by crook, we cannot avoid it. But for things that are outside the core, we also can create a milestone. And we did that to at least set a marker in the sand for releasing, right? Then from there, we go through a planning cycle or process. High level, and we're kind of doing this right now with Cluster API, or what are the high level objectives of things we want to accomplish? We're kind of trying to spec it out and scope it out first, and then sort of have a cut line. And that cut line will be the actual milestone. So nothing earth shattering, this is basic project management. Break down the work items and try to label them appropriately. So if you look at well-labeled examples, you can see things like in kubeadm repository, it's a color-coded extravaganza. The one thing that's interesting is that we try, if you're going to have something for a milestone, assign a priority to it, assign a person to it. So that way it's at least denoted that somebody is actively assigned to work on these things. And it's very much Athenian democracy in that if you volunteer, if you make your case and you want to work on this item, go ahead and let us know. And we will try to federate the work out where possible. Ideally, there are certain people who have a legacy or a history in certain areas, and they might get a little bit of, they might be the shepherd, so to speak, for this. But we also actively solicit and welcome new contributors because there's only so many people that are core contributors, and they are always overworked to the point where I wish Lubomir would go to sleep some days. But the idea is that we assign a person there, and they might have a shepherd. Once they're working on something, we mark it as active. This denotes that, like, hey, even though you're assigned something, that doesn't mean you're going to be working on it. It just lets people know that it signals that we're going to try and get into the milestone. Once it's marked as active, that means that other people shouldn't try to come in and come with patches, because if they do, then you can have conflicting patches on the same thing, and it's just difficult to manage from a project lead or from a SIG chair perspective. It just becomes kind of a little chaotic. We do go through regular cycles of grooming. Ideally, we do it actively throughout the milestone. So during an individual milestone, as it mentions here, we mark it as active once we're actually working on it. Then we do continuous triage. So ideally, for every single meeting that we have, we kind of go through new items that come in, and we determine if they should be met, this milestone or the next milestone. And then over time, it kind of becomes clear. We had the initial planning, and we kind of sort things into bins, and we just keep on executing. But we don't want to sort of conflate a milestone if at all possible. Right? Try to just cut a release and just iterate. The nice feature of having sort of time-based cadences is that you have another release coming. Just keep going, right? And there's got to be a cut line somewhere. Just keep iterating, get feedback. That's kind of the way the sig-cluster-lifecycle projects have matured, is by having these continuous releases. It allows us to get continuous feedback signal. The one thing that we do is that we're trying to be conservative on when we do promotions. By being a little bit conservative allows us to get extra signal back, and then we distill down that signal to make sure that we're trending in the direction that actually makes the most sense for the community. Otherwise, if we try to sort of push promotion too fast, then we kind of fragment ourselves and get ourselves in a bad situation. Last but not least is like, you earn your stripes in the community by chopping wood and carrying water. If you are active, if you help, if you do the hard work in the project, we will absolutely, reward those folks who are doing the hard work and the labor of the project, and promote them to reviewers and approvers, and get them in the owner's files. This is a community-based project. We want to empower people, and we want to see it grow over time. So if you are active and you want to get engaged, the best way to do it, the best way to start, is when you're looking at the original labels, look for help wanted issues. You'll actually see a bunch of them over time. Start by doing the things that are sort of easy to do, and then earn your stripes over time. Once you kind of understand the code base, then start volunteering as part of the triage. So when people are triaging new issues as part of the continuous triage within the office hours, then you can start to take up more responsibility, and it becomes a self-fulfilling cycle. I'll pause there. Are there any questions?
I just wanted to add, in terms of issues, that it's much better if you create a ticket for the feature you want to work on, or like the bug you want to fix first, because we want the visibility that everybody should comment on this first before you start the work, before, because you can technically start working on something that is 2,000 lines of code, and this can waste your time if like some of the maintainers decide to not approve your change. So it's much better to have a discussion even for the smaller things in a ticket.
Ideally, because the community is so large, like if I were to show you my PR backlog that I have to get through today, it's on the order of hundreds. So if you look at somebody like Team Hawken, that's just even an order of magnitude larger than mine. So ideally, break down your PRs into quantum. Even if it takes you longer to get from A to B, the individual steps make it easier for the reviewer. And the one thing you don't want to be doing is if you conflate a PR and you have multiple concepts baked into that PR, it becomes much more difficult to review and much harder to get your PRs in. So ideally, and this is like a lesson learned at such a project of this scale and magnitude, is that break them down into finite chunks where each chunk is a composable piece of the puzzle. And then if it takes you a little bit longer, that's fine. But that way you're getting your notice that you're making progress in this area. And that way it also it eases the burden on the reviewers too as well. One thing I should do inside of our document is link to the what makes a good PR doc. So that way, like for folks who are new to sig-cluster-lifecycle and they see our sort of grooming doc and engagement, then it links out to like what makes a good PR. And what makes a good PR actually spells this all out too. One thing you'll find is that there is actually explicit context written in the community repo. It's just that there's a lot of it, and sifting through it is not actually easy. So what might be beneficial is to have like a getting started guide to sig-cluster-lifecycle. And I can bake down some of those pictures too as well. We have T-minus 2 minutes. Are there any more questions that people have?
Well, one anecdote is the smaller a PR is, the more value it adds per line, which I think is a good metric. So yeah, always keep it in mind.
Yeah, but please, for the love of all that is holy, if you're going to make spelling corrections, bulk them together, please. Do not do individual PRs on spelling corrections.
Hey, Tim, I want to thank you and the team for putting this together. It was really super insightful.
Good. I'm glad it was useful.
Very much so useful. Very much so. Thank you so much.
Cool. I'm glad people got a lot out of it. And again, everyone's really friendly. Feel free to go on the sig-cluster-lifecycle channel. If you have questions, comments, complaints, concerns, we can always try to help route you into the right area. And if you're kind of new to the community, welcome. It's a very interesting and exciting place to be at. Right. With that said, we're kind of out of time. So thanks, everybody.
Thank you. Bye-bye.
Thanks.